Hello, in this lesson we're going to learn construction 10. It's the construction of a triangle where we have been given all three sides of a certain measurement. This is otherwise known as SSS for side, side, side. So a question might look like this. Construct, and then we have the symbol notation for a triangle, it's a little triangle, ABC. So those three letters therefore represent the three vertices, the points where the ends of the line segments that make the three sides of the triangle meet. And we are told the measurements of each of the three sides using the notation which means the measure of or the distance between A and B. So that's one side of the triangle is 6 centimetres, between B and C is 8 centimetres, and between A and C is 4 centimetres. So there we have the three side measurements. So side, 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 SSS. With this construction, it's really important that we do use a sketch because it's quite difficult to imagine what it might look like. So let's go ahead. So here's my sketch. When constructing triangles, it makes life much easier for us if we choose the side with the longest measurement to go as our base. So that means the bottom of our triangle, like this. And that helped me to know when drawing my sketch that as the three lengths are 6, 8 and 4, this is the largest measurement. So therefore my side at the bottom should be the distance between B and C. I then saw that AC is the smallest and AB is in between. So therefore it should look something like this, in that A must be closer to C than it is to B. Again, I haven't used any measurements. As you can see, this is quite small if you put it beside my rubber. So it's certainly not any accurate measurements there. But it has really helped me to know that I'm going to have BC first and which sides then are going to measure 6 and 4. So let's get started. So as we know from our sketch that if we start with our baseline, which is what we should do, the bottom part here, then we're going to need to start our construction quite low enough so that we can complete the rest of the triangle then above it. Now we are going to be using our ruler, but we're only going to use the measurements for this one bottom baseline only. The other two will be using another tool. Can you guess which tool it is? It's the compass. So let's start with our base of our triangle first, the line segment BC. We know it needs to measure 8 centimetres, so I'm simply going to draw with my ruler, and if you have squared paper, then it would be much easier to do it nice and straight along the squares that are printed in your book, making sure that we don't move our ruler and that is exactly from where 0 centimetres right up to 8 centimetres. So as you can see, if I just move my ruler slightly down, that bottom line segment of my triangle is exactly 8 centimetres. And then I'm going to label my points, remembering that I'm going to be drawing lines up. So I'm going to put the points underneath so they don't get in the way. There we have B and C, the base of our triangle. So as I said before, we're going to be using our compass. It's really important that we don't try to use our ruler to do the other two sides. You could start off by trying to draw a 6, but then this side won't join up to it, and it gets really quite messy. No, it's actually very simple once you use the compass. So how we do it is we start off by opening the compass width between the point of the needle and the point of our pencil to one of the measurements. So I'm going to do B to A first, which is 6 centimetres. So I'm going to make sure that there's exactly 6 centimetres in between those 2 points. So there we are. It's at the right measurement there, exactly 6 centimetres. So once we have made sure that our compass is open to the right measurement, then we're going to place the point on B. Remember that we're looking at B to A, so we have to make sure we put it on the right point. And then I'm going to sweep around, marking a good arc, and remembering then that that arc, wherever that arc is, it's always going to be 6 centimetres away from point B. Okay, so there's my mark. So it doesn't matter whether it is here, here, here or here, but that distance from B is always going to be 6 centimetres, and we know that because the compass width between the point and the pencil was 6 centimetres. Now that's what we're going to do for the other side as well. So we're going to change our compass width now to the 4 centimetres that's required for A to C. Once we're happy that it measures the correct measurement, so 4 centimetres in this case, then we again put our point of our compass onto the other vertex then, so that's C, because we're drawing A to C is 4 centimetres, and yet again we're going to sweep across. And what will happen is that the two arcs will actually overlap, and they will only overlap at one particular point, and at that exact point it will be 6 centimetres from B and 4 centimetres from C. So let's have a look. So there's our overlapping arcs, and we can see exactly that there is this one place, and that place, remember, all across here is 4 centimetres away from C. All here is 6 from B. So at this exact location, that's the place where we want to put our third vertex, our third point, point A. As with all our other constructions, we must not rub out our construction lines. So the examiner is looking to see these two arcs to show that you have used your compass. So there's only one thing left to do, and that's to connect then B to A and A to C. So we complete our triangle. And there's our finished triangle, and we can see that it does look quite similar to the sketch. Just be sure to label the points, and then we need to write on the remaining measurements like such. Notice how both of my lines, my line segments, AB and AC, how the pencil is exactly on the 2 points, that we haven't accidentally moved or slipped with the ruler. So it's really nice and accurate. And then of course it's quite easy to verify. We can check our work by using a ruler to see that it does in fact measure. There we have it, look, exactly 4 centimetres, and then this side we have exactly 6 centimetres. So that's how to construct a triangle when you're given all 3 sides measurements. So as before, we'll see it being demonstrated again with the computer. That sometimes makes this a little easier. So in this particular triangle, the measurements that we're going to be looking at here slightly different. So they want 7, 9, 9 being the longest. So that's starting at the bottom, and it's B to C. And making sure that you write the points and the measurement. Then we've got a side of 7, so we're opening the compass to 7, and that's B to A. So starting at the point B and creating an arc up the page. Then our last side is 5 centimetres, so opening the compass to 5 and sweeping from the other direction from C. Where they intersect, so we know that means where they cross, where they overlap, that's our third point, so A. All that's left to do is to very accurately connect those 2 lower points to A, and then be sure to mark on the measurements as well. Please pause the video to use your notes copy to copy this slide down. The steps and the various diagrams will help you with your revision to know what we did. Once you've finished recording it, then press play again, as we're going to learn that sometimes the questions aren't quite so easy. There are a number of other challenges that might come about, so we're going to have a look at something that might come up in your exam. So a typical question in the Junior Cert might be for an object such as a garden, like the worked example that's in your textbook, page 304. This shows the plan for a triangular garden as shown. And there you can see the grass, and we've got some measurements in metres. The question then says to construct an accurate scaled diagram of the triangular garden using a scale of 1 centimetres to represent 5 metres. So that means we're going to be constructing a triangle like we've just learnt to do, but we first of all have to figure out what the lengths need to be. We know that for every 5 metres, that is going to be 1 centimetre on our drawing. So what we have to do is we have to figure out how many 5 metres there are for each side, which means that we would divide the 40 by 5 to see how many 5 metres, and that will represent how many centimetres. And 40 divided by 5 then is 8 centimetres. So our first side is 40 divided by 5, 8 centimetres. We would do the same then for the remaining 2 sides. How many lots of 5 metres are there in 30? Because every 5 metres we're going to draw 1 centimetre. So 5, 10, 15, 20, 25, 30. There are 6 lots of 5 metres, so it's going to be 6 centimetres. 30 divided by 5 is 6. And the same then for our longest side, 45 divided by 5 is 9 centimetres. So now we have the 3 required side lengths, 8, 6 and 9. Okay, so now it's time to go on with the construction, and that means that you must begin with a sketch. So drawing your sketch, and notice how it's got these wiggly lines, and that's just trying to remind you that a sketch is not accurate, but I would still use a ruler. And you're writing on then, instead of the metres, the converted centimetres that we've just calculated. And that's then going to really help us when we construct. We remember that we start by constructing the bottom of our triangle, which is the largest of the 3 sides. And that's 9 centimetres, as our sketch showed, going from point P to R. So we would simply put our ruler down and draw this line segment measuring 9 centimetres with the ruler. So next, we have to then find where Q is, and we do that by creating 2 arcs, one a compass width of 8 centimetres from P. So we'll first of all start off by opening our compass width to make the needle of the point on 0, the pencil point exactly on 8, put the point on P, sweeping around. Now sometimes people make a mistake, they just don't sweep quite far enough. We want to make sure they definitely cross, so don't be afraid of going right up and right down. That's absolutely okay. Remember, the construction lines are what the examiner is looking for, but you definitely don't need to go underneath this line. And as we know, it's going to be above it from our sketch. Now it's time to start looking at the other end, the other third side, which is R to Q. So this measurement here is 6 centimetres. So we need to change our width now to be exactly 6 centimetres. And we put the point then on R, and we sweep across, making sure that we overlap our previous arc. And that is going to be the location for our third point, which we know is point Q. Now we use our straight edge to accurately connect those points P to Q and Q to R. And lastly, we must label our lengths. Your homework today is quite important. Not only do you get the chance to practice constructions, but you get to see how questions can be a little bit more tricky and not always quite so obvious. So, like always, once you submit your work, I will be sending you the solutions. Just for fun, what is a bird's favourite type of maths? Algebra, of course. Thanks for listening. See you next time.